Hello friends and welcome to another lecture on chemical engineering thermodynamics. This is Professor Arvind Prasad. At the outset I would like to say that there is an encouragement. My subscription is going up, but still the current subscription lies to only 690. I would like to make 1000 subscriptions to make this project viable. So once again request anyone who is watching this video to kindly subscribe my channel and forward these videos to students who would like to learn chemical engineering thermodynamics and ask them to subscribe my channel. Okay, we start. So the problem is from Mumbai University CET II paper. It's come on May 18 and the problem is 6b. You have the following reactions. A plus 3b gives you R plus 5s and A plus 5b gives you T plus 2s. So these are the two reactions. Now they are two parallel reactions. If the feed contains 4 moles of A and 10 moles of B, express the mole fraction in terms of reaction coordinates. Now that's 8 marks, and as you can see here, the 8 marks are just won easily. So let the reaction coordinates of the reaction 1 and 2 be epsilon 1 and epsilon 2, right? So a brief idea about reaction coordinates. If dn is the change in number of moles of any component in the reaction, then if you divide it by its stoichiometric number, it's going to be the reaction coordinate, that is epsilon. So what do we have is dn1 is equal to nu1 into epsilon. Now what is the reaction coordinate or the stoichiometric coordinate? You call the stoichiometric coefficient as for A it is 1, for B it is 3, for R it is 1. So these are the stoichiometric coefficients. So dn1, that is change in number of moles of 1, or A divided by its stoichiometric coefficient is going to be equal to epsilon. Now this can be written as dn2 by nu2 is equal to dn3 by nu3. And mind you, if it is a reactant, the stoichiometric coefficient is negative, and if it is a product, it is positive. But this ratio is always equal to the reaction coordinate, that is epsilon. So using this idea, now what do we get? We write it down as, let us say we have to do it for A. So we get dNA is equal to nu A, since A is a reactant, so it's going to be minus, into d epsilon, right? So we integrate it and we write dNA is equal to minus nu A, which of course is a constant, into d epsilon. Epsilon from 0 to epsilon, right? So what do we have is Na minus Na0 is equal to minus nu A into epsilon, or Na, that is the moles of A after the reaction, is equal to the moles of A fed into the reaction minus nu A into epsilon, right? So having understood this, we can simply draw a table and solve this problem. So the moles of A fed are 4, B fed is 10, R is 0, S is 0 and T is 0. Now let epsilon 1 be the reaction coordinate of reaction 1 and epsilon 2 be the reaction coordinate of reaction 2. So this we have epsilon 1 and this we have epsilon 2. So the moles of A after reaction obviously is 4 into the stoichiometric coefficient for of A for reaction 1, which is minus 1, into epsilon 1, which is the reaction coordinate for reaction 1, minus the stoichiometric coefficient for A in reaction 2, that is minus 1, into the reaction coordinate for reaction 2, which is epsilon 2. Similarly, for B, it's going to be 10 minus 3 into epsilon 1 minus 5 into epsilon 2. For R, it's going to be epsilon. As you can see here, the stoichiometric coefficient is positive 1. So it's going to be epsilon 1. And for S, it is going to be 5 epsilon 1 plus 2 epsilon 2 because S is a product. And for T, it is going to be epsilon 2. The reason being T is also a product and it has a stoichiometric coefficient of 1. Now, we sum up all the moles after the reaction and we get 14 plus 2 epsilon 1 minus 3 epsilon 2. Now, obviously, the mole fraction is going to be the moles of any compound, that is in the, for A, let us take the moles of A after the reaction is 4 minus epsilon 1 minus epsilon 2. So that's on the numerator, divided by the total moles, that is 14 plus 2 epsilon 1 minus 3 epsilon 2. Now, similarly, it can be written for all the compounds. Such a simple problem, and you get 10% of your exam paper. Such a simple problem, and you get 10% of your exam paper straight in. So remember one thing, that if you have understood the fundamentals correctly, then you can solve this. The fundamental is very simple. dN of any compound I is going to be nothing but d epsilon divided by nu I plus minus, where it plus is for positive, plus is for a product and minus is for a reactant. That will be all, my friends. Take good care of yourself. Goodbye.